Hello, my name is Victoria Henson, and in this video, I'm going to be talking about all the assignments that I completed in May 4001. The main focus of this course is to use technology in our teaching. So throughout the course, we completed multiple assignments where we covered technology and integrated those into our also our interns. For our final project, we were to put together an electronic portfolio that covered all of those assignments that we created. So on my first page, we talk about what the assignment is. It's part of our initial licensure requirement. We are required to create something that shows competence throughout this course using evidence. And in the first part, I talk about who I am, I talk about my major, and what I'm pursuing here at East Carolina University. Throughout this course, I have been able to learn so much information about technology. I learned that technology is not just our computers and our phones. Technology is literally seen everywhere. It's how our 21st century is literally coming together, how we function, our bankings, our electricity, our machines, how our cars work. It's all technology. And as a soon-to-be mathematics teacher, I feel that it is my job to ensure that my students are equipped with the information and knowledge that they need to know about technology. Through this course, we were able to explore lots of different dynamic softwares, and I listed a few: the Desmos, TI Nspire, GeoGebra. Students are able to input data, they're able to see graphs, they're able to see them move in real time, watch interactive videos. The list literally goes on and on. These resources are at our disposal as teachers, but we must be willing to challenge ourselves so that we can learn about them to then implement them effectively into our own classroom. As a teacher, I feel that I must continue exploring, researching, creating, analyzing, and implementing and evaluating techniques that will continue to grow for myself, but then also to be able to implement those for my students. So in this portfolio, I'm going to be talking about my technology philosophy, a TPAC lesson where I actually implemented this into my internship, where we were able to use Desmos. I recorded myself. And then we're going to talk about the resources. This is just a document that provides a lot of resources for a specific lesson. And then our artifacts, and then the media literacy videos, and then a lot of other class samples that we were able to explore. So first we're going to talk about the teaching. This is going to talk about into like the philosophy, the TPAC, and the resources. So the philosophy, this is where we wrote a paper and just discussed what my technology philosophy first was when we entered this class. I definitely feel like after completing this class, I would definitely implement a few more thoughts into the paper. Overall, I do think that technology can be successful in a classroom if both teachers and students are very open-minded coming into the lesson. Next, I'm going to talk about my TPAC lesson, and this is where I was able to go into my internship, have a lesson prepared, and then actually teach this lesson to my students using technology. Next is my resources, and this is a project where we were told to find and explain different types of resources that would be helpful to teach a lesson. And I chose geometric transformations. I chose geometric transformations because I do not feel very confident with geometry, so I felt like this would be a good way to challenge myself to find more resources to help me be a better teacher when it comes to geometric transformations. So to dive a little more into my TPAC lesson, this is where we went into our internships and implemented a lesson with technology. And the lesson covered correlation coefficients and linear regressions. The students started with a warm-up to cover the previous day's information, and then we led into a guided note sheet, and then they worked on an in-class worksheet, and then to summarize, we did an open discussion to tie in any loose ends of the lesson. So students were utilizing Desmos as their technology piece in the lesson. When we were working through the guided notes, we went through a few vocabulary words, and then we actually went into seeing data, and then that's when the students went into Desmos and inputted that data into Desmos, and then Desmos gave them the answer of the correlation coefficient. Overall, I was able to co-teach with my clinical teacher very well, but something that I would change about the lesson is throughout the guided notes, in the very beginning, there was a chart to talk about the strength of the correlation coefficient, and I felt that it was I felt like I could have implemented a better chart for them to visually be able to see and to determine the strength of the correlation. Based on the SAMR model, I do think that this lesson is at the augmentation level. I don't think that it was a direct substitution because there was a change in the lesson. So I do think that the Desmos functionally improves the lesson. So this is why I would classify as the augmentation level. Next, I would like to dive into my assignment where we were asked to provide resources for a certain lesson. And for my lesson, I chose geometric transformations. Like I said in the beginning, I don't feel that I am the most competent in teaching geometric transformations. So this assignment allowed me to dive deeper into different resources that I could use. And I felt like this was a great assignment for this challenge. So if we click on the link, it opens up to what types of resources that we actually explored. So in the beginning, I listed my standards, talking about geometric figures and rotating them, translating them. Here I provide the North Carolina Math State Standards, where I actually got my standards from. I also listed the Common Core. This is just basically what are we actually talking about? What is the mathematical concept that I'm trying to cover? I provided an article, a GeoGebra, where basically we're just introducing geometric transformations. And then a short video clip that also covers the different types of transformations. Next, we go into how can the technology be used to help students learn. And this is where I chose things that can enhance students' learning, where they can explore, they can expand, and then they can find accurate ways to really understand the geometric transformations. So I did a Desmos activity, a GeoGebra task, a longer YouTube video. It is a little cheesy, but it's like a song that'll kind of help them remember the different types. And then a Quizlet talking about the different types, the rotation, reflection, dilation, and then another Desmos activity where this just allows them to deeper understand the types of them. I put in here that it would be used at the end of the unit to basically be a review. Next are instructional strategies that can be used to teach the concept, talking about how I would specifically teach them. So I implemented a Khan Academy, Math is Fun, an article that we could read. Pinterest, this is where I have images and designs where I could print them out to give them talking about the key characteristics of the different types of geometric transformations. And then lastly is what assessments that I would use. This is where I just found a few, Kahoot is a really good one that allows the teacher to see the students' understanding right then and there. How many students are actually getting the problem right? Different types of PowerPoints, a Google form to question the students. So next I would like to talk about my technology philosophy. And this is that assignment that we did in the very beginning of the class, and it was basically an overview of what we thought our technology philosophy would be in our own classrooms. And I did express that I thought that once technology is implemented in the classroom, the focus kind of shifts and becomes more student-focused. Talking about the different types of technology devices, how the students can create, analyze, and explore. So this is the link. So for this assignment, this is where we actually talked about how we would benefit and use and create the technology for our classrooms. So in the first paragraph, the conceptualization of learning with technology, this is where I go in to talk about how that these tools are necessary. Learning in the classroom with technology can only benefit a student if it is implemented effectively by the teacher. I do strongly agree by that these technology resources can be absolutely amazing for our students, but it is our job as teachers to be able to implement them in an effective way for our students. With teaching with technology, this is where the classroom hopefully will have access to the different types of technologies. People sometimes take this for granted, and when you walk into a school and they don't have those technology resources, it is a challenge for those teachers to find it. But nowadays, most of these technology resources are found in the schools, such as pens, papers, protractors, the smart boards, different types of things. When we get into softwares, students could be exploring YouTube, Desmos, Padlet. But it is, like I said, the teacher's job to have an understanding of what these softwares are to then to be able to implement into their classroom. Technology, like I said, is not only used in mathematics. It's literally seen in every subject. And hopefully, as a mathematics teacher, I hope to plan to implement technology tools as much as possible. So for the goal of the instruction, I do believe that technology is essential to learning. It is influential. It also enhances student learning. These are the different types. We're providing our students with the essential complex examples, giving them insightful resources, how they can relate this math to real-world examples. Next, I talk about how I would assessment. I feel like assessment is very vital for a teacher's learning. This is where we have the opportunity to reflect. We have the opportunity to go back and look what we might change to make it better for the next class. The teacher, I talk about specifically Kahoot in this paper, where teachers can see in real time if the students are actually understanding what is going on. The teacher can pause. We can ask if there is any questions about that specific question that we just had. I feel like we must not only assess their students for their grades, but also to study those results to ensure that as a teacher that the students are understanding what we are covering. And in the conclusion, I talk about how group work can be effective, how we utilize the different types of models, the PURIA model, where students will be planning, using, recommending, integrating, or even the SAMR model, where we use technology to substitute or augmentation, modification, redefinition. What types of tasks are we implementing as teachers to challenge our students? Implementation, using those different types of resources. Next, I would like to talk about the artifacts that we completed in this class. So for Artifact 1, this is where we were talking about trig functions. We were using the online dynamic software Desmos, and our students were told to investigate how the variables of the parent function affect the graph. Students were using sliders to be able to determine what those variables do. So in my investigation, I actually answer the questions that I would have students be determining what happens to the graph as A varies. And as you can see, I have implemented different screenshots of what actually happens when I have different values. So when A is less than 1, you can see that the sine function is stretched out. And when the A value is greater than 1, we see that the function begins to have an increase. So students will be exploring these all types of questions, and the investigation, like the warm-up, allowed me to answer them and see what students might put as their own answers. So talking about the different variables of A, C, H, and also B. And then I go into, I did create a lesson plan for this, and this is the exploratory lesson plan. So we're talking about our learning objectives, our essential questions, the different standards, what type of materials, and then first, we started the lesson with posing questions, talking about what they know about trig functions, how they might see them in the real world, and then then they go into the small group investigation, where they have about 30 minutes to go into Desmos and complete the Desmos task. I do list some here examples of how students might answer, talking about, they will be looking at like the definitions of what an amplitude is. And overall, I thought this task was very, very well put together, I thought. We also go into a whole group discussion afterwards, where they're going to be talking about, each group will be talking about a different variable and creating a presentation where they'll, creating a poster to present their findings. Then finally, we will do a summarizing and extending It's a kind of like an assessment type, where it's a Google form where they can talk about what they determined or what they learned in the lesson today. So I also did have the IDP and also the reflection for the Artifact 1. So for Artifact 2, this is where we were given an assignment to divide a irregular quadrilateral into 2 even areas for 2 brothers. They had an island and they needed it to be divided evenly, and so I asked the students to utilize Geometry Sketchpad to determine how we would do that. So in the investigation, I explore again what are possible answers for the students that they might use. They're asked to look at a different shape possibly, and then also another method that they would use to determine how to divide the irregular triangle. I also do list my lesson plan, and this lesson plan is an LES, so this is where we launch, explore, and summarize, my IDP, and I do also have my reflection. Personally, I would implement both of these lessons into my own classroom, because I do feel that they are very strong, especially the first one when we are exploring the trigonomic functions, where they're able to move the sliders and see on their own how the variables are affected.